greetings, the Astro 30 here, yet again with another box of PCBs to open. So we'll have a look at what we've got here. I made this particular set of PCBs for a reason. The reason will become evident in later videos, but as with that power supply module that I built, I now know that there's an issue with fitment of some components. So we've got two sets of PCBs in here. One is a 15 plus minus volt series pass regulators to provide a plus minus 15 volt regulated supply to a preamp, plus a plus 12 volt output. The other board is a flasher unit or multi-vibrator, which I did discuss in another video, but I've made a PCB for it. So I just need to open this bubble wrap so we can take a board out to look at it. Yeah, I've just put scratches into the desk, but oh well, it's my desk. I mean, the quality of the board is pretty good. It's just that my measurements are out. So there's the PCB there, and yeah, I've used the same footprint for one of these heat sinks, and yeah, it's not going to fit. So it just means that I'll have to negate the pins on the heatsink because it's not going to fit otherwise. So the quality is up to their usual standard. So in this video we're going to build up this little regulator supply board and test it out and see how well it works. Okay, I'm going to start the construction off with the low profile resistors here, the 10Ks. There's only 6 of them. I also noticed that these footprints for the 220 microfarad 25 volt ones are too small for the capacitor that I'm going to use. So I'm going to change it to 100 microfarad. It's not really that important what capacitance is here. It's only just to, just keep the regulated output stable. So that's only a slight modification. I mean, you could probably jam the capacitors in there, but yeah, I don't want to do that because it may make it look stupid. So that's what I'm going to do. Is I'm going to start with these 10K resistors and solder them in, because I've got a couple of open packets of these with like only a certain amount in there. So I don't know why I've got 2 packets of 10Ks open. So I'll just put these in the right way around so the electrons don't fall out. I don't know what it is, but there's something very therapeutic and relaxing about assembling a PCB. I guess because you don't really have to think that hard about things. It just becomes like, automatic, and you just do it. I mean, there is thinking involved where you've got to like make sure you put components in the correct places and stuff like that, so you're not, misassembling the board. But as I said, there's something fairly therapeutic about assembling a PCB. I just love doing it. I guess that's why I love making or having PCBs made. I don't make my own PCBs anymore because by hand, because it's very time consuming, especially when it comes to drilling the holes. Plus it's a lot more difficult doing double-sided boards. So that's the resistors installed, so I might as well install the 3 JST connectors I'm going to need. There's also a PCB pin I need to put in here. In fact, I might do that first, considering my PCB pins are handy. So I will just get one of them out of my bag. I've got way too many. I only need one. Because as I say, I'm not sure what I'm doing with these at the moment. So I'm going to leave them off for now until I can come up with a better solution. So this I can actually solder from the top because it's convenient. Just heat it long enough so that it travels down. Well, it didn't actually travel to the other side of the board, and that's alright. I can just heat it again. There we go. That's soldered. So now I can pop my connectors in. Maybe. Maybe not. I'm just wondering if that ground pin is really close. Oh, that ground pin is very close to that connector. If I use a PCB pin header connector here, it'll still plug in, so, but you wouldn't want to try and solder to that. So yeah, what looks good in the CAD program doesn't necessarily mean everything's going to fit right. Because yeah, definitely that 220 microfarad will not fit there with that connector because, well, the spacing is so close. So it would have to definitely be 100 microfarads. Even 10s will work in there too. As I say, the capacitance is not that big of a deal of what you use. Just as long as, well, there's a capacitor there and that it works. It only just provides a little bit of filtering. Okay, those connectors, that one's not straight. Now it is. So now I can solder the rest of them pins in and fix up the first ones. Just redo my first pins. Make sure they're soldered properly, which they are. And there we go, it's starting to take shape. Great. Yes, they're a little bit crooked, but that's alright. Next thing I probably want to put in now is, whilst I'm thinking of it, is the 3 transistors here. And that'll probably do it for this part because I don't have the rest of the parts. I've got the larger transistors, I just don't have all the heat sinks. Okay, so let me get a couple of BC547s and a BC557 and we'll solder them in. Okay, so I'm actually reusing a couple of BC547s off of another circuit board, which is a failure. In fact, I might actually just trim where they were soldered off so I can get them in the board properly. Only reason is because that circuit board's no longer useful, but the transistors are still fine. So might as well reuse them rather than using a brand new one, because there's very little point using a new one if you've already got one. Okay, that's the transistors soldered in. I mean, this particular PCB shouldn't take any longer than half an hour to assemble. That's including messing with these up here. So that's about as far as I can go with this at the moment until I get the xenodiodes, the resistors here. Actually, come to think of it, I do have 3 of these mini TO 220 heat sinks, and as I believe that there's not going to be that much current draw on this particular circuit, what it's going to be used for, like the plus minus 15 volt rails are only going to be probably no more than 20 MA. These heat sinks should do the job. I mean, if they don't, well, I can always change them. But yeah, yes, they're not mounted to the PCB, but at least, you know, there's a heatsink there, and I've got the transistors, so I might as well install them next, but I've got to actually prep these heat sinks with some heatsink compound and some screws, etc. So that's what I'm going to do right now. Alright, so I've got my transistors and my hardware here and some compound. Now I'm just going to apply the compound to the back of the transistor like I normally do, rather than on the heatsink because it's less messy that way. So I just have to make sure that I get most of the liquid part, watery part out of this stuff. That's way too much. Okay. So that's easy enough to cure. Just use another transistor and rub some of the excess off onto the other transistor. And let's apply a little tiny bit more on that one. Okay, so this is going to be the fun part, is trying to get the transistors onto the heatsink or heat sinks without making a humongous mess. So I believe these 5mm long screws are going to be long enough. I need to wipe the crap off the front of that, because that wasn't supposed to happen. And place the screw through the hole. Grab a heatsink. Place that on there. And the screw is just long enough this is very fiddly. So I just have to make sure that I get the right transistor in the right hole. That one is a 139. That one is a 140, so that one goes there. Again, make sure you put the correct polarity transistor in the correct holes, or else it will not work. And that should be a 139, which it is. I'm going to have to order some more 139s. I've only got 3 left now. And I can mount them flat to the board like that, so that's alright. Make sure that these end pins are soldered correctly, because they're only just tacked in. Perfect. Now, I'll trim off the excess lead length, like so. Get out of there. Right, that is now soldered in. Yeah, leads are a little bit how you doing. But sweet, so that means now I can go about tightening the heat sinks properly. Doing this cack-handed, but yeah, whatever. That's 1, 2. Don't have to like overly crank them down or anything, just so they're tight. There we go. Yes, that one's slightly bent, but that's alright. So far there we have it. We've almost got a complete circuit board here, and I believe there's enough compound on there for it to, you know, transfer the heat. That one's probably got a bit too much, but that's alright. So there's our output transistor series pass elements. And yeah, they'll be fine. They shouldn't experience much movement. I do have one 220 microfarad capacitor 50 volt, which I might as well install now because, well, why not? Once I can find the thing. There he is there. So I'll just put all this stuff to the side now. I could have waited until I've got some more capacitors, but I don't think it really matters at this stage. And there is still just enough clearance near this PCB pin, which has now got heatsink compound on it. So that should be perfectly fine. So I can still solder the other components in from the other side when I get them. So it's not a great issue that I'm putting a larger component in now. It's perfectly fine. That's perfect. Alright, trim that off. So it's starting to look like a circuit board. Well, it was already a circuit board. It's just like it's starting to actually look like something, not like just a blank circuit board. I'm going to have a look around, see if I can find any 100 microfarad 25 volts. I don't think I've got any. But I'll have a look and see what we've got. If not, I'll have to go and buy them. And as well as these resistors, and the diodes. Apparently no, I don't. So that's not going to be very useful. I've got a 4.7 microfarad 50 volt, but that's no good. This is the issue I'm going to have. This is a 220/25, and yeah, they're not going to fit in the footprint properly because they're just way too big. As we can see there, it's going to interfere with the resistors, and this one over here is going to interfere with the connector. So yeah, I'd have to use like a 6mm round capacitor instead of the one I'm going to put in there. Alright, so the next day, and I've got the parts that I need to complete it apart from the 5.6 volt Zener, because they're $1.45 and I didn't have $1.45 at the time. So I'm going to install the rest of these components bar the 12 volt side one, because I noticed that with this 25 volt 100 microfarad capacitor, if I can get it back in the holes, it is coming into close proximity with that connector, but it should still be alright, I think. So I might leave it like that, just solder it in. So I might as well put the capacitors in, seeing as they're conveniently handy. I'm just going to trim them off of the band strip because, well, it saves trying to pull them out. These cutters are next to useless now. Okay, so these ones here, however, will clear it just fine. Just got to remember to get the polarity the correct way around. Like that. And lucky last. Okay. And I might as well put my 220 microfarad 50 volt cap in. Probably should cut that off the band too, but whatever. Right, that goes that way around. Alright, so I'll solder those in, put the Zenos in and the two resistors, and then we can test it. Alright, everything's assembled apart from the 12 volt side, but that's okay for now. I've got it hooked up to a power supply at plus minus 19 volt thereabouts, going into my input. These flying leads here are just to measure the output, and so now I can turn the load of my power supply on. Alright, nothing much happened. So now I need to measure my output voltages. So having this connector in here makes it awfully easier. So according to this, I've got 9 volt there, but that's probably because the input voltage isn't high enough, which is fine. So I'll measure the negative side now without shorting anything. Don't appear to have anything. Right, well that appears to be a complete and utter disaster. Right, now we do have a negative voltage. It was my input connector wasn't giving me the negative rail. So I have to reconfigure this now. Alright, positive 9 volt, but that's only because the voltage is probably too low going in, and -10. So there we go. The little regulator circuit is working, so I'm going to turn everything off now. And to finish off this video on this regulated circuit board here, I thought it might be a good idea to actually hook it up to the power supply that's going to be powering it in the end. Your case may differ. Basically, this is just why the positive and the negative, the VCC and the VEE, goes to the positive and negative supply rails of your power amplifier, power supply, etc. So I've got my multimeter hooked across the positive and the negative output portions. Yes, it's a yellow wire, not a black. The black's here, it doesn't matter. It's just how that connector is made. So I've got it hooked up to my dim bulb just to make sure that everything's, fine. So I'll turn the dim bulb on, and what we should see at the output across the multimeter is roughly 30 volts, and we've got 33 there. So I know both supply rails are going to be present. That I can verify by moving my negative probe, well, maybe, to the ground. No, it doesn't want to work that way. Okay, so I'll connect it to the ground of the circuit over the other side. There we go. So we've actually got 16.5 volt there on the positive side, so it's a little higher than expected, but yeah, it's within where it should be. But then again, the circuit's not loaded either. So I'll try and move my meter over to the negative side now on the positive probe, like so. Negative 16.4, close to negative 16.5. So yes, the rails are working. So what I need to do now is I'll just turn it off temporarily, is I need to load the circuit. So I'm going to put a 330 ohm resistor across the positive and the negative outputs, which will give a total current draw through the circuit of roughly 90 mA, which is going to be about 3 times the amount that's going to be drawn on this circuit anyway, but it's a good stress test, I guess. Okay, the 330 ohm 5 watt resistor is connected across the positive and negative. So now if I turn the device on, wow. Okay, that was unexpected. Yeah, there seems to be a voltage drop happening here, and I'm not sure why exactly. Could be the resistance of my wires, but I doubt it. Even when I connect a 12 volt relay, which has roughly a 44 milliamp current draw across the 16 volt output, it buggers off right down to 5 volt. And yeah, that's not right. And even with the load resistor across just the positive output and ground, we're getting 6 volt. Yeah, that's practically useless. So there's something wrong with my design here. That's unfortunate. Probably means I'm going to have to redesign the circuit. So I'm not going to release this as a PCB because it just doesn't work. 10 mA, it drops off down to 13 volt, and it shouldn't be. So I did test this circuit up on breadboard, and it appeared to function fine at the time. But yeah, I don't know what's going on. So I'm still going to release this video, but I'm not quite happy with how this turned out, because it should be allowing more current to flow than that without reducing the voltage. So I might redesign the circuit board to use LM317Ts, because they will handle an input voltage difference of 40 volt anyway. So well, a 317T and a 337T respectively for the negative going side. Yeah, just to get those rails. It'll make the circuit a lot simpler too. Anyway, yeah, that was kind of a disaster, but yeah, whatever. So I'm going to leave this video here because, well, it's not performing the way I wanted to. But yeah, it is what it is. So anyway, if you enjoyed this video, please remember to go down below, comment, rate and subscribe if you haven't done so already. And this is the Astro 30 saying see you later. I'll catch you in the next one. Thanks for watching.